Alright, so what we're talking about today is a new way of measuring angles. And this new measure we're going to use it's called a radian. And so what we're going to do is discuss what is a radian, how did it come about, and why is it useful. So consider a circle, and we've got two circles over here, and they have different sizes, different radii. This top circle has a radius of exactly 4. This bottom circle has a radius of exactly 3. Now, here's the deal. We know right now that every circle has exactly 360 degrees in it. I mean, we know that. That's something we take for granted. We take it as given. But here's my question. I mean, what's a degree? Why do we use degrees? Where did it come from? Why is it that there are 360 of them in a circle? We could just as easily decide that some new angle is called a degree, and maybe there'd be more than 360 degrees in a circle, or fewer than. So the idea of a degree seems a bit arbitrary. It doesn't really have anything to do with what these circles are. So what a radian is a way to define angle measures that comes from the structure of circles. So we got to define what is a radian. So let's look at this top circle right now. It's got a radius of exactly 4 units. So what a radian is suppose I take this same exact distance of 4 and I start tracing that around the outside of the circle, and maybe, I don't know, that's about 4. And what a radian is this angle right, give me a moment, right there. That angle is 1 radian. It's the angle that you get when you take the length of this radius and you trace it around the outside of a circle. So there's 1 radian. Now here's the cool part. If we take a look down here at our circle of radius 3, well, will this measure be different? All right, so we're going to take this 3 units and we're going to drag it around the outside of the circle, and there's about 3 units, give or take, kind of eyeballing it. And if you look at these two, that angle looks and should be exactly the same. So what's really cool is that it doesn't matter how big the circle is. No matter what, as the circumference gets larger, so does the radius, of course. And they get larger in proportion, so that this angle measure, 1 radian, is going to be the same for every single circle. Okay, so that's what a radian is. Alright, seems like a pretty kind of tough measure to work with. Let's see what 2 radians would look like. Of course, I'm going to be eyeballing this whole thing, so it's not going to be perfect. So let's go another 4 units on our top circle. There's another radian. And we'll do another radian. It looks like 3 radians is almost enough to go halfway around the circle. And then we say, well, here's my question. How many radians would it take to go the full way around the circle? Well, let's think about this. I know what the entire length around the circle is, the perimeter or the circumference of the circle. I know that the circumference of any circle is 2 pi times the radius. Well, heck, each one of these radians has the length of 1 radius. And so, how many of them does it take to go all the way around the circle? 2 pi of them. And here's a way to kind of tie that in intuitively. How many of them does it take to go halfway around the circle? 1 pi, or 3.14. And check it out. So far we've got 1, 2, 3, and a little bit to go halfway around the circle. And so we can say, for instance, we can do our first angle to degree to radian kind of comparison. That 360 degrees is equivalent to 2 pi radians. Now, I mean, this is really tough stuff. We're used to speaking in degrees and having degrees pretty much only in integer amounts, right? 32 degrees, 45 degrees, 68 degrees. What's crazy about radians is we very rarely ever say 2 radians or 4 radians. We always say something like 2 pi radians or 1 pi radian. Well, let's find out some other important angle measures. So for instance, I claim that if 360 degrees is equal to 2 pi radians, well, if we divide both sides of this equation by 2, I think 180 degrees is equal to pi radians. Right? We've almost drawn that right here. There's 3 of them, and a little bit more makes 3.14-ish, or exactly pi. Let's divide by 2 again. 90 degrees, this distance right here, or excuse me, that angle right there, well, that's going to be, well, I just divided both sides of this equation by 2. That will be pi over 2 radians. And these are very important conversions to remember all the time. We can go even further. 45 degrees, well, I just took this equation and divided by 2 again, is pi over 4 radians. And then some other helpful ones are going to be 30 degrees, and all I have to do to get that is divide both sides of this equation by 3, or multiply both sides of that equation by 1/3. So that's going to be pi over 6 radians. And just for good measure, I like to know what 60 degrees is as well. And all we do is multiply both sides of this equation by 2. And we get 2 pi over 6, or pi over 3 radians. And so that's what a radian is. And this is a few examples of some really important degree to radian conversions to know.